So this is video number 4. Video number 4 is going to cover the visualizer. This should be relatively quick. The main improvement I have for my visualizer compared to last quarter is that I have a cheap and semi-effective way of taking care of an instance where I'm calling multiple renders on objects that have different collisional states. So if I shoot a bullet at a soldier, but it's also testing collision against the tank, I want to make sure I can visibly see that collision. So there might be an off case where my B-sphere will appear blue in that frame because even though there is a collision with the bullet, since the tank comes second, and that's not colliding, it would appear blue or non-collision. So the big change that I did down here at the bottom is I have 4 lists. I have 4 lists mainly because if I keep them short, iterating through them is the same as iterating through one massive list. And granted, it would be much better if I did my own list, but timing was a factor. So for the private variables, I have my singleton. My visualizer is here. I have a default color that everything defaults to. The default color is blue. In this case, if I'm calling to render a B-sphere, an OBB or an ABB, and I call it on the default color, it will go into the not collided list. And if it's a different color, one that I have user defined as a collision, it will go into the collide list. Under this idea, I will basically render all the not collides first, and if something overlaps, I'll render the collide afterwards. And since the collide afterwards has rendered, instead of appearing not colliding, it will appear that it has collided. I have two wireframe objects that the visualizer owns and deletes and takes care of, and that's a unit B-sphere and a unit box. So I only ever have these 2 game objects that all I do is come render time, I set its position and I render it there, render it there, render it there. I'll go into that later. We have the public API, which is a B-sphere, an ABB, and an OBB. One of these basically calls the other, since it's just the calculation that's different, but at the end it gets placed into the box list since these are both boxes. Moving on, we have the double dispatch right here to show our collision volume. This will eventually call one of these depending on whatever our collision volume is. And as I've shown in the previous slide in the draw, we have a render all call, which will render all of our collision volumes when the time is appropriate. Going into the visualizer, as I mentioned before, we only own a unit sphere and a unit box right here. This is not the color red. It used to be red, but I decided to go with blue. So each of these have their default colors set as blue. I'll go into further down. This is our double dispatch. We go into our appropriate call. If it's a B-sphere, we get our scale and our location, and we send that information for our render our B-sphere. If we have an ABB, we get our location through its information, and our ABB is the same information, but we have to multiply it by the world matrix in order to get our local min and max point in world space, since that's all the information we have in an OBB. And through these 2 commands, the render ABB is the same call since they're both boxes and they both have the same information at this point. They get placed into their appropriate list. So if it's a B sphere and the color is the default color, meaning it's not a collision, it gets placed into the not collision list. And if it's a different color, then it goes into the collision or collide list. Same thing for our ABBs, except it goes into our box list. And then our render calls, basically, we first go through our spheres that have not collided. Then we go through our ABBs that have not collided. Then we go through our spheres that have collided and have collided. I know you've mentioned that the good idea is to use a command pattern with a recycling pool. I wasn't quite sure which direction to take that. Under this case, I'm placing things in these two lists because there is the possibility that that if I use the command pattern, I'll constantly trip up things being double rendered, and that happens a lot of the time. There's an instance, like I mentioned, where you can have 5 different things calling the same render sphere on an object, and if they keep calling each other, I feel like the command pattern will slowly break through that. We do show our things, and like I mentioned, we set our unit box or a unit sphere to the appropriate size and color, and then we just basically tell our scene, render it there, render it there, render it there. And we pop all this information since it's just what we're end up pushing is just a visualizer data struct of a position or of a world matrix of the position and a color. So again, this stuff is just placed onto the stack and then just gets removed on a pop when I pop from the front. Moving further on, our render all. I think I've mentioned that. Our support class for colors. I took some time to create this support class. This support class is the exact same one that was used in graphics. It has all the colors that were given to us in graphics, and in the CPP, they're all the color values. This is also available in the Hummingbird core. So when a user goes in and just writes Hummingbird core, they're able to access all these colors when they need it. That should cover the visualizer. I know I don't have the command pattern as you've requested, but that was my justification for why I did it in the way I did. It may not be the most effective way, and the command pattern may indeed be the better way to do it. Maybe I just justified it in the wrong context. So that's what I did.